Hello, this is Jack Ingram with Lab 3, the Black Hole Lab. So the introduction for this lab, in this lab we are observing a star orbiting a black hole. We will be observing the motion of the star in order to find its net force. The only force acting on this star is from the black hole. We will be using GlowScript to build a model to predict the motion of the star, and we will use Newton's second law, the momentum principle, and Newton's universal law of gravitation to find the net force. So the fundamental principles, first, Newton's second law states that the acceleration of an object is equal to the net force divided by the object's mass. And then Newton's universal law of gravitation states that a particle attracts another particle with a force given by the following. The gravitational force is equal to constant g times mass 1 times mass 2 over the distance squared. So using the starter code, I made adjustments to make the calculations. So the first thing I did was set the initial conditions. So we set the value of g, the given mass of the star, and then the delta t that we'll be using for this lab. For calculations, I made a number of changes here. So the first thing I did is set delta v to be v final minus v initial, and delta p to be p initial, or p final minus p initial. Then, since we know that the net force is the the derivative of momentum with respect to time, using delta t, we can do calculus basically to find our net force. Then we can find the parallel and perpendicular components of that net force. And then at the bottom here, you can see that we moved around the equation from Newton's universal law of gravitation to find the mass of the black hole. The final changes I made, I set the position and axis for the three arrows. So we have the net force, the perpendicular force, and the parallel force arrows. So this is the output of my GlowScript. You can see the net force, the parallel force, and the perpendicular force, as well as the arrows. I still need to answer the two what if questions, but yeah, this was Lab 3 draft.